Hi, everyone. Thank you so much for having us. Like he said, I'm Christy Cardenas here. I'm an investor in the nuclear power space, and I'm excited about our panel here. So I'd love for you all to introduce yourselves, if you might, and just give us maybe 2 cents on, nuclear and energy security before we dig in.
Yeah, happy to do that. Thank you, Christy, and thanks again for the kind invitation to speak this afternoon. My name is Roland Backhaus. I'm a career nuclear energy person. I graduated from the Naval Academy in 2001. I served on U.S. submarines for a long time, taught nuclear engineering and English at the Naval Academy, and have since been a nuclear energy regulatory and transactional attorney and professional, both at law firms and at a variety of advanced reactor companies, and most currently at Vistra Corporation. Vistra owns and operates 4 nuclear sites in 3 states, 2 in Ohio, 1 in Pennsylvania, and 1 in Texas. So thanks for the opportunity.
Good afternoon, everybody. I am Chuck Fleischmann. I am the chairman of the Energy and Water Subcommittee of Appropriations in the United States House. I represent the 3rd District of Tennessee. That has the great Oak Ridge Reservation. That's how I got involved with their national labs and everything new nuclear and old nuclear. So I write the energy and water bill for the House appropriations. I've done that 2 years in a row. I'm focusing on everything from new nuclear fuels to new nuclear designs. I work with these gentlemen up here. Key to our energy needs in this country, nuclear is about 20% of the base load now. In my part of the world, it's 47%. We need to see that grow and increase. Nuclear is clean, it's reliable, it's safe, and it's resilient. Thank you.
And Jeff?
Well, I'm just a dumb guitar player. I don't know what I'm doing here, but somehow or other, I ended up working for the Department of Defense for 25 years. I've got 25 years at Lawrence Livermore. I've got 20 years at MIT Lincoln Labs. I was still with the Missile Defense Agency, and have been involved in things nuclear, let's just put it that way, both in terms of generating energy and also on the weapons side. So, but mostly here to talk about what the our honorable congressman here wants to talk more about is the peaceful uses of energy. A little later on, though, I'm going to touch on some other aspects of the nuclear question.
That's right. So we have a nice group of experts here to set the stage a bit. We are racing towards AI supremacy here in the United States and across the globe. Tech leaders like Amazon, Google, and Microsoft are turning to nuclear because, as Chuck mentioned, nuclear provides safe, clean, and reliable baseload power. Many believe that a nuclear power renaissance is underway, but the development of new technologies has been slow, and the construction of new reactors has been stymied for decades. Many cite regulatory and financing challenges that are too burdensome to overcome, and we have the added complexity of increasing geopolitical tensions and sort of a double-edged sword when it comes to nuclear. So with that, Jeff, I'd love to get your take, just given your long career with the Department of Defense and the government labs, on the perspective from that piece of the government and, a couple of the solutions that you think are exciting and being developed now.
Well, we've come a long way since the Atoms for Peace program back in the Eisenhower administration, when people started giving some serious thought to how could we harness the power of nuclear energy for civilian, non-destructive, and beneficial applications. And there's been the first nuclear reactors were, on some level, somewhat like anything first generation, probably not the most efficient, but at least it started it out. And then the Navy, Admiral Rickover, decided that he was going to develop a small nuclear reactor to power a submarine. And that really started the pathway to small nuclear reactors and the ability to make and generate energy from a nuclear source that's very small. And then as we progressed in history, second generation, third generation, now we're up to fourth generation. We're at a point now where I think the new generation of nuclear technology is safe, clean, very efficient, and has some ability to solve some of society's problems. And I don't know if I have the slides with me, but there's a kind of a nuclear fuel called triso, which is basically a piece of fissional material that's clad in ceramics that, I mean, if you ever bake donuts and you've ever put the little sprinkles on the donuts, they're about that size. And when you pack them together, you can use them to create energy. Now, the good news is a terrorist can't use it for anything. And if you build a small modular reactor and drop it in the ground for 40 years and develop 800 megawatts, 80 megawatts of power, you'll never even see it. And so there's no pollution, there's no problems, there's no fear of going critical. So we're at a point now where we can actually, in a sense, create nuclear batteries. And one of the areas in the Department of Defense that I'm involved in is how do I distribute power in the United States? Right now, there is a lot of malware in the United States SCADA systems, industrial, communications, power, et cetera, et cetera, et cetera. We're very vulnerable. The bad guys can just flip a switch, and we're in deep kimchi. So the question is, how do you prevent that, or how do you ameliorate that? Well, one is, instead of having a few power plants, what if you had 2,000, and they were not connected on the grid, and they were all distributed, and each military base had their own power generating system? Now, all of a sudden, you've basically taken away some of the big advantages of your adversary. So we're at the point now where nuclear energy is not only going to supply us with energy, but it is going to prevent and defend the country's interests. And the last thing I'll say is, with the new generation of nuclear reactors, we're now in a position where we don't have to worry about what happens to a nuclear reactor in a conflict. If you all remember the Russians making big noises about what they were going to do to the nuclear power plant in Ukraine, that's basically taking a civilian nuclear reactor and creating a weapon. That, with the new reactor technology, that's no longer the case. So we're at the forefront, the threshold of being able to have a very, very exciting and safe nuclear future.
Yeah, thank you. And Jeff, I know that we talked a bit about nuclear, the overlap of nuclear and space. Can you give us just a high level of what that looks like and what you're excited about there? Of nuclear and space.
Well, again, when Admiral Rickover came up with the concept of a very small nuclear reactor to power a submarine, people started saying, well, okay, let's have a look and see if we can power some other little things, like satellites. As a matter of fact, Voyager 1 is still, it's 350 million years, 350 million miles from Earth and still going. And that started in 1977. A small, tiny thermobaric nuclear reactor is still powering Voyager, which is still sending messages and information back from beyond the solar system. So obviously this is workable. As we begin to proliferate in space, millions of satellites literally we're going to have, power them with nuclear energy and being able to move them inside the solar system and then outside the solar system and outer space is a tremendous advantage for the idea of small nuclear power. And we're going to see more and more and more of this because if you want to explore the planets, there are not a whole lot of options. Chemical rockets are very inefficient. So the idea of being able to do planetary exploration using nuclear power is very, very attractive.
Well, Chuck, looking at you next. Your role in the U.S. Senate has you uniquely positioned for visibility into the government's appetite to advance these types of technologies. Can you give us a sense of where things stand and even kind of a sense of priority relative to other needs.
Sure, thank you very much. Obviously, I'm privileged to represent one of the largest Department of Energy reservations in Oak Ridge. It's got Oak Ridge National Laboratory, it's got the Y-12 NNSA facility, we're building the uranium processing facility, and we have a large legacy cleanup. That's about $10 billion worth of federal investment there. But in my role as Cardinal, as Chairman of Energy and Water Appropriations, I fund the Department of Energy. And as part of that, in the bills that we craft, we work with the administration and we work with our friends in the Senate who are pro-nuclear to try to come up with the best path forward. Looking at this from a current standpoint, we're 20% base nuclear right now nationwide. These are the larger nuclear power plants. We are extending their life. Things are going well. We just did build at Vogtle in Georgia a large nuclear power plant. So nuclear is going well. But where is all the interest? It's in these small modular reactors, advanced reactors, and micro reactors. Why is that, and what's the priority? Well, first of all, fuel. Many of the new designs work with existing fuel. That's LEU, that's enriched uranium to about 5%. Some of the new reactors, and Skunk talked to this a bit about the Generation 4s, they will require something that's called HALEU. That's enriched to about 19.5, 19.75%. We don't have enough of that right now in the United States. We just put a ban on Russian HALEU. So what is important? We need to get the front end of the fuel cycle right, the back end. Let's talk about that. Some of the folks who are skeptics about nuclear, and they shouldn't be, do raise one valid concern. What are we going to do with the spent nuclear fuel? Now, you notice I didn't say waste, I said spent nuclear fuel. Our friends, the French, our adversaries, they have reprocessed this. Russia has reprocessed it for years. It can be done. In the United States, we don't do that. President Carter stopped it. So I've put money where our hearts are into reprocessing. So we've got American companies now looking at reprocessing. So we've got fuel, we've got designs, we've got front end and back end of the fuel cycle, and we have unprecedented capital from the private sector coming in. So we've got great companies like TerraPower, X-Energy, GE Hitachi, Oklo, I'm naming a few, that are all out there. It's a competition. I put the dollars up, and then the Department of Energy, our great secretary, and he's a good guy, you should get to know him, Chris Wright's doing a great job. He will have to have the arduous task of picking those that win those competitions. Thank you.
Yeah. And I think so. Chuck highlights the importance of public-private partnership, which is absolutely critical to any sort of infrastructure project, but specifically with nuclear, where we have such deep technological risk on the advanced reactors and such a huge upfront capital cost for the mature reactors, it's absolutely critical to getting it done. And I think you both did a good job of talking about why nuclear is great and sort of the big dream in the nuclear option. Roland, I might ask you to comment on some of the challenges, and particularly so many people cite regulatory as being the challenge and the problem. I'd love your thoughts.
Yeah, so thanks for that. And this is an issue that I feel pretty passionately about. So if I start to scream, just feel that. The message is that regulatory issues are hurdles to building unsafe designs. They also ensure that the designs that we build are safe. It's probably true that we can have some regulatory efficiencies that can streamline some things and probably mete out some problems in a more efficient way. But the idea of pointing the finger as to why we can't build nuclear in the United States well at the NRC honestly doesn't land very well with me. And the reason is it's just too easy. It's just too easy to say, NRC is the problem, NRC you're expensive, NRC you're inefficient, and you're preventing the construction of all these projects. Because it kind of gets the people that make that point off the hook. You know, where do you go if that's true? It basically prevents you from having to do something to fix the problem. So I kind of wholly reject that. And also, I would challenge folks to actually go into the NRC and talk with people. I think what you'll find is a building or buildings full of professional people that want to build safe plants. That's why they have this job. So that's the first thing. So I don't really see regulatory as the problem. I see regulatory as a way that the public should have confidence that the plants that we build are safe. That's the first thing. I really see four impediments or four structures that we do need to put in place to actually build nuclear in the United States. The first is demonstration projects. You know, we need to demonstrate that we can build nuclear power on time, on schedule, and on budget. The way you do that is by demonstration projects. Those demonstration projects can actually be hooked to the grid if you want to actually have some revenue from them, but they don't need to be either. These are proof of principle projects that exercise the supply chain, they exercise value streams, they bring banks, they get people talking in smart ways. That's the first thing. The federal government's done a great job in the last couple of years with ARDP, the Advanced Reactor Demonstration Project, which funded 10 companies to do very important things in nuclear research and also deployment. And then more recently in the Gen 3 Plus program, which DOE is now funding, authorized up to $900 million to develop and advance light water reactor designs. There's a bunch of reasons for that. So first, demonstration projects. We need to do more of that. That shouldn't fall, by the way, to the federal government. That money should come in from private, it should come in from state, it should come in from banks, and the rest. There's no reason why this should be a problem. The second thing is fuel. Like Jeff was saying, fuel is a problem in the United States. We have long since stopped mining and milling and enriching and converting and doing fuel fabrication in the United States in a way that's consistent with the growth of nuclear power in the United States. Rather, we import 25% of our fuel from Russia, from Tenex, for our existing reactors. That's a problem. This is the point that the Congressman talked about a moment ago, about the ban of it, the tiered ban of the import of fuel from Russia as a way to spur domestic supply chain, as a way to spur domestic investment into this area. Very important, fuel. And that sets aside HALEU. You know, HALEU is manufactured by the same centrifuges that manufacture low-enriched uranium. So really, you're going to have a squeeze on the enrichment step of nuclear fuel manufacture. It's a critical problem that we need to overcome. Thirdly, financing. You know, the federal government's done a great job with the production tax credit, with the investment tax credit for new nuclear. I suspect that states could weigh in and do nice work in tax credit space. Tax credit's very important because it lowers near-term risk. It lowers near-term investment risk and low-term execution risk to advanced reactor developers in the near term, and which has the effect of being able to bring in private capital on the back end of some of those near-term risks. So thanks for that. Also, states can do that. And, you know, anyway, I'll stop on that. I get all excited about that one, too. Fourthly is taxes and typical investment. You know, the Loan Program Office is a wonderful federal-funded vehicle that deploys money smartly, often, or maybe most of the time, depending how you think, that really frees up the influx of private capital into this space. In 2022, Congress gave $5 billion to LPO. That $5 billion investment into fund LPO brought in $220 billion of private money. It's 2% of the money that was ultimately created came from the federal government. So that's the kind of thing we need to continue to see. And we can see it at the federal level, and we can also see it at the state level. So those four things: demonstration projects, fuel, financing, and taxes. Not NRC, you're terrible, we don't like you, you're an impediment that we can't possibly overcome. Wrong message.
I think you made a variety of good points, one of which is the private financing. So maybe let's start there, and then we can come back to the ecosystem required and the public-private partnership. Back to you, Chuck. But to give you a sense, the average nuclear fission power project has had north of 200 to 300% cost inflation, up to, in some cases, 8 times as much as they expected the original project to come in at. And this is sort of a question for all of you. Clearly, none of us have cracked the code. We've got on one side of this, everyone's so scared of the upfront costs, And then we've got the advanced reactors that are unproven and there's just deep risk there. How do you see any routes that we can pursue to de-risk this for the private sector? And this is specifically in light of the budget constraints that we're under in the federal government perspective.
Well, thank you for the question. I am neither going to advocate nor speak against this, but you've hit it on the head in terms of the first of a kind. It's going to be very expensive. Some members in Congress, particularly Senator Risch from Idaho, has worked to basically put forward an idea of cost overrun insurance. So how would that work? That the federal government would stand in the gap, God forbid, if a specific project were to overrun. So it would entice those who might put capital at risk. But the first of a kind is going to be more expensive. There's no question about that. But with these modular reactors, we don't want to build one. We want to build 10 or 100 and market them to the world. The real problem, as I see it, is China and Russia can build these, can finance them, they will fuel them, they will run them, and they will take away the spent fuel. What I'm hearing from all over the world leaders come and meet with me. They said, Congressman, when we meet with you and the Americans, we get a lecture. When we meet with the Russians and Chinese, we get a plan. So we have got to put a plan in place, not only domestically, but also that we can market what I think is a superior American technology to the world.
Yeah, and maybe just to follow up on that, and I agree with all of that, you know, the issue really here is supply chain. That's one of the things that really drives delays in projects and therefore extends the period of time during which financing is applied, which is about 80% the cost of a build of a new project. And the reason that supply chain is tricky is because we've made these reactors really large. There's only so many places in the world where you can get a reactor vessel forging, for example. 2 is the answer. And so and we've got a number of those for not just vessels, but also for labor and you know, instrumentation and control and the rest. And so that problem is exacerbated when your reactors are really big or when they're very powerful. They have a lot of uranium in them, or they have a lot of Curie content, or they have it's a high pressure system or something. So one of the other things, a very practical thing, by making reactors small, especially in the case of high temperature gas reactors, they operate at a very low pressure. And the second you have a low pressure system, you don't have a big, thick forged components. You can have rolled components. You can have components made out of stainless steel, whereas historically they might have needed to be carbon steel. And what happens, for example, and that's just a little microcosm, but imagine that 1,000 times. What happens, instead of getting 2 vendors that can provide that service or 2 vendors that can provide that hardware, you get hundreds of vendors. And a disproportion of those vendors can be in the United States. They need not be from Korea, and they need not be from Japan. So that's another way that you can drive down the cost, is by minimizing the number of supply chain choke points, both in services and in hardware, just by system design.
I think that, you know, kind of the supply chain point is important. And if you look at the bigger picture, I think there's 11 critical energy equipment segments, and across the value chain, China controls about 80%. So we have a clear issue when it comes to the geopolitical situation and the trade war and all of that. You know, how can we go about building out not only these individual reactors and incentivizing that activity, but doing the workforce and the supply chain and these kind of broader based challenges that we need to build out in the United States, so that in 20 years when some of these technologies mature, we can, you know, still control energy leadership across the globe?
Well, just have a hard look at how economics works. When they invented the automobile, people, oh, the automobile, that's big and ugly and expensive. But you need tires, you need petroleum products, you need roads, you need nice hats to wear when you're driving. This spurred an incredible economic boom. And when people really begin to study and understand what the second and third order of effects will be from a nuclear technology, for instance, one of the advantages of a high temperature gas reactor, small modular reactor, is the ability to produce hydrogen. Probably, since it's the most abundant element in the universe, for one thing. Number 2, it's an extremely efficient energy source. So what would happen if you for instance, used the natural gas pipeline network in a country and used that to distribute hydrogen from small modular reactors. Now you're creating another economy, which means now you can probably power manufacturing at a much lower price. Maybe you will even be able to power and create enough energy so you could run massive server farms. Now, all of a sudden, as the orders of effects keep going out and out, now it starts to become prescient. Now it starts to become advantageous. It's just a question of people stepping back, having a hard look at it, and building a model, an economic model that you can show has benefits and will get cheaper and cheaper. I mean, I don't know how much it cost to make Tang when the NASA did it, but right after that, you could go into a grocery store and buy Tang. You didn't have to pay like $1 bazillion from a government grant. You just could buy it in a jar. So somehow or along the line, the efficiency grows when the need and the economic model is applied.
Yeah, and I think supply chain is actually the trickiest piece of this. It's people, it's labor, and the reason is the nuclear market has been in a downturn since 1979 or maybe the mid 80s, and that's why you don't see a lot of people like me, like mid 40s people on stage, because we weren't hired, for a long time. So there's this hole of people in the industry. You have a lot of very senior people that have got great experience, a lot of junior people that want to learn and they appreciate the upside and all this, but you don't have sort of 20-year career people. There's very few of us out there. And so there are ways to fix that as it happens, like all things, right? Unless you're willing just to point at the NRC and say it's your fault. Come on, that was funny. And so, and so the way to do it really, I think, is to, a little bit, is to foster engineering programs in colleges. Some amount of money given to colleges to promote nuclear programs there goes a long way. We're not roping people into nuclear programs. They might want to go into material science or, electrical engineering or what have you, but these are all disciplines and trades that funnel towards, hard engineering, which is what we really need to solve some of these problems. I would say that's the first thing. And the second piece, and now I'm thinking about nuclear engineers, the second thing is a build out of the trades in the United States. These are people that, they lay fiber and they lay cable and they know how to hang piping and they know how to do non-destructive testing on piping. These are all very important jobs if you're building a $1 billion power plant or a $5 billion plant. But again, not nuclear. So even if nuclear doesn't go anywhere, we've still got these skilled tradespeople, many of whom can be retooled from their existing. And that, again, opens up these supply chain choke points that I talked about a minute ago. I think things like that solve supply chain in a disproportionate way to the amount of money and effort that it takes to get them moving.
Feel free.
Totally agree with the gentleman. One point I want to make. We're in the great state of Texas. I can't say enough good about Texas. I love you all. Thank you. Best line of the convention. But I hail from the great state of Tennessee. Our governor came out with a plan, and other governors are looking at this. And we talked about states, $60 million to invest in new nuclear. We are attracting industries, nuclear industries, to the state of Tennessee. The French, Orano, who enrich uranium, they also reprocess, have made the biggest deal in Tennessee history. We took some monies for that fund and put it into workforce development in our junior colleges and at my alma mater, the University of Tennessee. So we're creating at the state level, and several other governors have already come to me and said, Chuck, how did you do it in Tennessee? This could be a model where we could actually go out. Texas is ripe for it because you've got Texas Abilene, Christian Abilene. It's got a great program. Texas A&M by far is one of the best in the world. They actually work at Los Alamos. They do tremendous work. But the reality is Governor Youngkin came to me and said, Chuck, what do we need to do in Virginia? So we're having the state step up as well as the federal government. Critically important.
I think you made a couple of good points. I'd like to hit on the people point, but come back to the opportunity for international collaboration. On the people, and this is a bit of a leading question here in Texas, do you see market adjacencies where we can repurpose the technical talent and engineering workforce that we have in place today with some level of upskilling to kind of bridge this gap. Because to your point, we're really trying to go from 0 to 60 in the nuclear industry right now.
Yeah, the way to think about a nuclear plant is it's got two pieces. As a nuclear piece, it's a hot rock. It's made hot by the fission of uranium, and then it's got some coolant loops on it to take that heat away. And then it's got just basically very fancy turbine generators on the backside. Those turbine generators look a lot like the turbine generators that are in existing fossil plants or coal plants or whatever. And so the folks that work, we call that the balance of plant. There's the nuclear plant, and the balance of plant is that non-nuclear piece. So that's almost one-for-one adaptation or adjacency, as was your word, for the people that know how to maintain and operate and construct and repair that balance of plant. Those people are already here. They're here, they're in Texas, they're elsewhere. Those jobs are replicable, they're good jobs, they're high-paying jobs. Then what you have is you need your nuclear people that have got some experience operating nuclear power plants, being licensed to operate nuclear power plants, and doing repair on nuclear power plants to do that piece. The third bit is sort of the extra adjacent. So these are nuclear security people, site people, staff people, all the policy people that actually do the real work at a power plant. The point is, it's only a very small fraction of people that design and fabricate and repair nuclear power plants that actually need to be nuclear engineers or nuclear pipe layers or have a license from NRC to do that. The vast majority of the people that are actually on site every day or at headquarters or whatever are non-nuclear people. So the answer is yes, but I think it's disproportionately that way also.
That makes sense. And the part of the reason I ask is just nuclear is an interesting solution because it is power. To Roland's point, you're dealing with a steam generator, and a lot of power plants use that type of generator, but it's also a fuel. And so that gives us a unique control in transportation and is something we hear in Texas like, fuel. So I think it's just something to think about. Chuck,
Let's get down really quick. Let's get down to fundamental principles. Very sophisticated concepts. 3 things. Scare the crap out of somebody. Figure out a way to make a profit and make it cheap. Now, when you say repurposing engineers, if an engineer says, well, I'm doing okay making tires, we mean there's this whole new world of nuclear, and I'm an engineer, and all I have to do is learn a little bit more, and now I'm going to be able to make an even better living for my family, et cetera. Whatever it is, it's the incentive. You can talk about the technologies, you can talk about everything. But the bottom line is creating incentives. Certainly that's part of Chuck's thing is you are going to create incentives for people to want to do this. You're going to, and you start again with the server farms. People are screaming. Power grids at the moment can't even come close to supplying the amount of power needed to run server farms to support AI and Bitcoin. So that is a need. So if somebody can articulate this well, then everything else will follow. I'm not saying you don't have to go to school and understand these things, but there are some pretty simple concepts. It's just explaining it to people and showing them why.
I think, Jeff, you're right, that clear communication is easier said than done, And then the other piece that I think is really interesting between you and Chuck both is just these data center power and grid squeezes are extremely localized. We have one in Dallas, there's one in the Virginia area, and so that makes the resolution of these infrastructure squeezes also a regional issue. So the states really can't afford to not pay attention to this. And on the other side of it, it's really, we have this sort of nuclear option that has great upside potential. And so, Chuck, I'd love your thoughts on just that and the importance of states in this equation. And then on the flip side, what opportunities you see for further international collaboration.
Excellent question. The states are so important. Again, I give my governor, Bill Lee of Tennessee, kudos because he was the first to come up with this nuclear fund to attract new businesses to Tennessee. Now, when they come, typically, not always, but typically they come near the Oak Ridge area. Oak Ridge is a city that is west of Knoxville. It sits in 2 counties. Both counties I represent. I don't represent Knoxville, but it's very furtive. You've got the national lab there that can actually help these businesses. You've got a workforce and a community that is infinitely pro-nuclear. So it is built in from the Manhattan Project forward. But our states, and I've talked with many governors, and Bill Lee had the governor of Nebraska, Virginia, Wyoming, and others come to a conference, and we want to expand that, get more governors in the room, working with their state legislators to rebuild the nuclear industry. Talking about international, we in Tennessee hosted the first World Nuclear Forum, and we did that because we wanted to invite countries that were friendly to the United States, and let me be specific, France, South Korea. I think you alluded to the places where things can be built. South Koreans are doing tremendous things in new nuclear. The Romanians and other countries, they came and we had a collaboration. Now, what do we really need to do? The United States, these countries will tell you, we do not want to do business with Russia. We do not want to do business with China. But what are you going to do to incentivize us? We need a financing mechanism, and that's going to be the key. So right now we're talking about XM. I've actually sat down with folks at the World Bank. They're not warned with this, and I have to respect that. But we've got to have something, if we're really going to collaborate, and we're doing that academically, we're doing that with technologies. Poland is another country that just loves American technology. They love the GE Hitachi Gen 3. They love Westinghouse. Canada, and Canada is our friend, doing tremendous work in nuclear. So working with our friends and our allies, collaborating, sharing when we can share, but we're going to have to get that financing mechanism down so that we can incentivize that. And I will close by saying this. Our friends in Africa are very interested in new nuclear. I'm going to be specific. Ghana is speaking with us on a regular basis, but we've got to be so careful because our adversaries go in there right now with a better incentive package. And if we lose that, we lose geopolitically as well. Thank you.
Yeah, I think so it all comes down to the money, which was a comment Roland made before the panel, which I completely agree with. There are 2 complexities to highlight when it comes to private capital financing, and it really is about risk, but also the depth of pockets required to undertake projects like this, and that's both on the advanced technology side and the existing fission reactor side. There just aren't many players that can handle this type of capital expenditure risk. The other piece of that is that I'd like to discuss a bit now here is timeline, which is the other tough piece. On the venture capital side that's financing a lot of these new small modular reactors, these funds are 10-year funds, maybe they extend to 12, but we're talking pools of capital that require near-term returns. I'd love any of your thoughts on just the timeline expectations that you're seeing in the market, both for if the contemplation of existing technology reactors and then new reactors. I don't know, Roland, do you have a perspective?
Yeah, I do. So first, the Vogtle project, in my view, is a huge win for nuclear. There are taxpayers in Georgia that would argue with me maybe on that point. The project was over budget, it was delayed, et cetera. Well documented, don't need to get into it. But the fact is we demonstrated that we can actually build nuclear in the United States, which before that wasn't a foregone conclusion. Okay, so that's the first thing. The second thing, as I would say, is that although that project was a 28 or a $30 billion project at the end of the day, developing small modular can operate at a fraction of that. So each company will talk about the cost of their deployment strategies and the rest, but let's assume it's 10% or which is maybe about right, or maybe a third of that. Just because that that capital is a lower cap, brings different players into the field. Different stakeholders, private money, public money, and the rest can be in that space in a smart way, not a stupid way. But they can still be there. There are more people that can be there. The second thing is that, there are opportunities for folks who want to be there. You can come in earlier in investment space with a higher risk, but also a higher potential rate of return. And then as projects get closer to FID, then those early stage investors might exit, and they might have less risk averse, investors that want a lower rate of return come in later in the project life cycle. So all that to say is, the projects are eminently more investable because they're small, because the amount of capital required to get them done is algebraically less, and then also, therefore, you can do more with traditional financing. You can think about financing more like, a large gas project or, a bridge or a dam, and much less like, the biggest of mega projects, which would be like a big AP 1000 or an ESBWR plan or what have you. Those are just two quick thoughts.
I think those are helpful. What I've seen, 10, 15, 20 years. It's like, it's going to take us a long time to figure out the tech and the regulatory hurdles and all of that. And that's speaking to both the small modular reactors and, the big dream, nuclear fusion, right? And I bring that up just because it will require a very steady hand on the side of policy and government support to really get us there and have, go after the long-term big giant opportunity. And Chuck, I don't know if you have any thoughts just on the timeline that will require to get policy and capital commitment solutions in place from the government.
Well, we spoke earlier about the Nuclear Regulatory Commission, and I've spoken with David Wright, who's going to be the new chair, and he is basically committed to me to move more swiftly, to talk to his colleagues and get that going a bit faster. So those timelines are there. I think there needs to be a clear delineation between where we are now. Fission is right now. We need to put our resources there. Fusion is for the future. Now, we're seeing a lot of capital being poured in on the private side on fusion. And let's face it, my Democratic colleagues line up in mass when we talk about fusion, not so much on fission. I'm getting more of them. I'm the Republican lead on fission and fusion because I want to make sure that I'm even-handed with this. But the reality is there'll be different regulations for fusion because it's a different technology than fission. But timelines, we've got to watch the competition. Russia, China, France, South Korea, Canada, they are all moving ahead. India has some interesting issues in and of itself because they use some different fuels because of their indigenous sands and things like that. But the reality is time is of the essence if we're going to win this battle over civil nuclear. If we lose it, we're going to be dependent on foreign sources for all of the above, for the fuel, for the designs, and the like. I think that would just put us in a disadvantageous position.
I think that, Jeff?
Well, again, it's thinking about opportunity. For instance, the United States maritime commercial capability is next to zero. Everybody else builds ships. Everybody else ships our goods all around the world. What if somebody in the United States government said, you know what? We're going to become a maritime nation again. What we're going to do is we're going to build ships that are nuclear powered. That means that the operating costs to move goods and services across the oceans, once the initial investment is made, zero. What would that do and how would that change the whole maritime architecture? It's things like that that will provide the incentives, I believe, to make this happen. Again, I go back to my 3 principles. Scare the crap out of them, figure out if you can make a profit, and make it cheap. That, I believe, fulfills all 3 of those philosophical tenets. And I know it sounds maybe a little simple, but if you apply that to a number of different things, you will come up with opportunities that will, and not only will you be able to change, for instance, right now, China is the maritime king right now. And because things are changing and the climate is changing, the Northwest Passage, in other words, being able to ship goods and services via sea near the Arctic Circle and above Canada, is now opening up to be profitable. Well, okay, how many more opportunities do you need? I mean, check this box, check this, check this, check this. And then, by the way, you got to feed people. Well, to feed people in a lot of ways, if you're going to build fish farms or you're going to do things like that, needs power. Again, and other industries will grow from that. For instance, shipping goods across the oceans used to be able to just make money from shipping goods across the oceans. And then the liquor manufacturers realized, wait a minute, if I put a keg of whiskey in the hold of a ship, I'm going to be able to age it much quicker than I can if I do it on land. That means I can make more booze, sell it cheaper, and make a profit. Again, it's looking at the opportunities, having smart people look at the possibilities and the opportunities to push this. And I think nuclear is perfectly situated for that.
Yeah, I think I did want to draw a distinction between fission and fusion. You know, fission generates 20% of the electricity in the United States today, as Chuck mentioned, and fusion, we just barely have produced energy with it at the smallest scales at Lawrence Livermore. So they're two universes. They're different points. And then I think we're just out of time. So maybe just any final thoughts, and really on the stakes of the global race here. What do we have to win and what do we have to lose?
Yeah, we need to win. We should be treating this as a moonshot moment in the energy industry. We need it for grid stability. We need it for national security. We need it for energy policy. We need it to power, computers and AI and everything else. And then, by the way, our grid is not particularly stable as a result of electrification. So there's basically no way that we can afford to lose this, because if we lose it, that means somebody else wins. It means we're going to end up buying their product, which means we're going to be beholden to their ability to, cut off fuel supply for us and the rest. So this is a moonshot moment. We can't screw it up.
One final point, the geopolitical benefits or detriments if we lose. If we win this race, we will be in the position where, whether it's South America, Asia, really anywhere, even in North America, we will get all of the geopolitical benefits of that, even in the Middle East. If we lose, our adversaries will get into that space and maintain it.
Well, and I'm kind of hopeful. Winston Churchill said famously that you can always rely on America to do the right thing after they've exhausted every other possibility. Now, he said that from love, because his mother was American, and he had a tremendous amount of love for America. So if you think about that for a minute, once we get this moving, there's no stopping it. And we have the resources, the intellectual capability, we have everything that we need in this country to make this happen.
All right. Well, thank you for hanging with us.